Hey, welcome back to Mr. Nelson's chemistry class. Today we're going to continue working on stoichiometry. We're going to go again from mass to mass. We're doing this with practice sheet number 3, problem number 3, and woohoo, it's the last one for this particular practice sheet. So we only had 3 of them. So here we go. Here's this last one. We've got a couple things in here that are a little bit unique if we haven't went over the nomenclatures, and so we'll make sure that you have all of those. So we're going to start off with, as always, we have our steps. Again, these steps are things that you need to know. They may not always be there. So if they're not there, you need to know that progression of how to go through it. And as always, you need to make sure that you show your work. If you don't show your work, you can't get credit for it. But more importantly is I can't show you where you made your mistake. I can say, well, yeah, maybe your molar mass is off, but where did you make your mistake in your molar mass? Did you put the wrong thing down as far as the atomic weight of something? Okay, so make sure that you write everything down, do it step by step. If you do everything the way that I do in the video here, hey, you'll be good. Okay, we all make mistakes. Even I make mistakes. You'll see that in a lot of my videos I make mistakes. Maybe you can catch me. Hopefully I can catch myself before I get to the end. So let's go ahead and start off. Here's our problem. When hydrochloric acid reacts with sodium sulfate, table salt, sodium chloride, and sulfuric acid are produced. Now I put in the formula for the acid right here, but in some classes we didn't get a chance to go over how to name acids. But acids are really simple. This is what it is. You answer them just like you do an ionic compound. The charge for hydrogen is the metal, and the charge is a +1. Okay, so the charge of the non-metal, which is either going to be binary or polyatomic, is going to be whatever that is. I just have to have that many hydrogens because hydrogen is 1. So we'll never have to put parentheses around any polyatomic ion. So here's a polyatomic ion right here, or not a polyatomic ion. This is chlorine. And again, the reason we know that it is because the word hydro. Hydro means no water, so there's no water in the beginning of it. Let's go down to the next one, sulfuric acid. Well, sulfuric, it goes with 8. You should know the phrase eitic itis. So 8 goes to ic, and ite goes to us. So if I go backwards, if I see the word ic, that means that it's us, or it's 8, so it's sulfate, and there's no hydro, so that means there is oxygen, so we have to put sulfate down. So if I go ahead and put my parentheses in here, I'm going to go back, and I'm going to have H, acids always begin with H, and I have sulfate. Now sulfate is actually SO4, and what's the charge of sulfate? So let's go ahead and look at it and find that charge of sulfate. We'll go ahead. Here's sulfate. It's SO4. It's a -2, so that means I have to have 2 hydrogens. So let's go back to our problem. And so we know that we're going to have H2 and then SO4. And so there's the nomenclature or the formula for sulfuric acid. Okay, so let's go ahead, and since we're doing this just like anything else, we have those. We have sodium sulfate. Let's put the charges in for sodium sulfate. Sodium, let's just go to the sulfate. We know that the sulfate is going to be a -2, or 2 minus, whichever you want to put first. But what is our sodium? Our sodium is going to be, since it's in column 1A, that means it's going to be a +1. Okay, so we're going to go +1. I could look at my period, or at my chart that I have here in the middle, okay, which is right here, and there's sodium. It's a +1. Now 1A is +1, 2A is +2 in that group. So let's go back to the questions. And the question, now I have sodium chloride. Now again, sodium chloride, sodium is going to be a +1, and chlorine, and it would help if I actually put a 1 there, and chlorine is going to be a -1. Now, how did I get the -1? Again, if I go back to my here, chlorine's right here. It's in 7A. It needs 1 electron to be stable, as over here. Remember, sodium gave up that 1 electron that it had. Chlorine has 7 valence electrons, so it needs to gain 1 to be stable. So it's going to gain an electron, which is a negative charge. That's why it became a -1. So let's go back to the problem. And we did sulfuric acid. So I have the formula for hydrochloric acid, for sodium sulfate, We know that they do not cancel each other out, so we're going to crisscross. So that means I'm going to put a 2 right here, and we're going to put a 1 right there, a 1 right there. And then I'm going over here. These do cancel out, so we're going to have 1 of each one. So let's go ahead and go down to the equation and write out the skeleton equation or the unbalanced chemical equation. So we're going to start off with our HCl. Add to that, we're going to do our sodium sulfate. And if you remember, sulfate was SO4. I got it from right here. But I need 2 sodiums, so we're going to put Na for our sodium and a subscript of 2. And then we're going to put our sulfate, SO4. And I only needed 1 of those, so there's no parentheses around that. Okay, now what's going to happen is that's going to produce our sodium chloride, NaCl, and our sulfuric acid, which we already have up there, so we're going to add to that H2SO4. And we're going to put our molar mass over here. Once we calculate that out, is going to equal and put that over there. So now the next thing we have to do is we have to go ahead and balance this skeleton equation or unbalanced chemical equation. So we're going to write down the elements that we have on each side. If we have polyatomic ions that are on both sides, we're going to try to keep those together. So we're going to have hydrogen, chlorine, sodium, and then we're going to do our polyatomic ion, because since I have it on both sides, SO4. Now we can separate it, and sometimes it doesn't work out when we keep it together. But I'm going to tell you right now, I've been doing this a long time, and it's probably about 99% of the time, if you keep it together, you're good. But remember, every once in a while, it might be that one time that I give it to you that it's not. So we're going to go ahead and say how many do we have on each side. So on this side, we have how many hydrogens. Well, if I look over here, this side here, I only have 1 hydrogen. We go by the subscript. So we're going to go ahead and put a 1 in there. Chlorine, there's no subscript, so there's only 1 chlorine. Sodium, there's a subscript of 2, so there's 2 of that. And then there's my polyatomic ion. There's no subscript because I don't see any parentheses around it. So that means that I only have 1. Okay, and I like to try to keep those maybe a little in line. So now we're going to step over to the other side of the equation, and we're going to write the same elements there. So I have hydrogen, I have chlorine, I have sodium, and I have my SO4. Now, what do I have of each one on this side? For hydrogen, I have a subscript of 2. Okay, so that means I have 2 of those. Chlorine, I don't have no subscript, so that means I only have 1 of those. My sodium, no subscript, so I only have 1 of those. And my sulfate ion, look at that, I only have 1 of those. So where am I different? And where am I the same? Well, I like to keep hydrogen to the end because hydrogen is one of those things that kind of tends to work out. My chlorine's good, my sodium is off. So let's go ahead and work about the sodium. Okay, my polyatomic ions are good, so the only thing we have off really is sodium and hydrogen. So let's go ahead and work about the sodium first. So I have 2 sodiums on this side. I need 2 on this side. So the only way I can do that is, again, we can only change the coefficients, not the subscripts. So we're going to put a 2 there, which now I have 2 sodiums. I have 2. And we're going to get rid of that. But I also have chlorine too to change my chlorine. So my chlorine now is 2. So we're going to go ahead and get rid of that one also. So I'm going to chase my chlorine over to the side. So I'm going to put a 2 right here. Okay. So I have 2 chlorines over here. So we're going to change that to 2. And we'll get rid of this one. But it also affected my hydrogen. So now I have 2 hydrogen. Okay, so now I have 2, 2, 2, 2, 2, 2, 1, 1. Let's double check and see what we have. I have 2 hydrogen on this side. I have 2 hydrogens on this side right here. I have 2 chlorines because of my coefficient. On this side, I have 2 chlorines because of my coefficient on this side. My sodiums, I have 2 on this side. I have 2 because of my coefficient on this side. My sulfate, I have 1 here on this side, and I have 1 on this side. So we should be balanced. So our number is going to be 2 to 1 to 2 to 1. And again, we'll go ahead and make that bold and change the color nice and bright so we can see it. So there's our molar mass. So you're calculating on the molar mass, you got to show that. So once I have the molar mass, I have that center part in that stoichiometry problem. So let's go ahead and go back to what we need to do. So we have our balanced chemical equation. We have to start our stoichiometry problem. We're going to start with the mass in the problem. So here's the mass in the problem. I have 20 grams of hydrochloric acid. I need to figure out how many grams of sulfuric acid will be produced. So we're going to go from this right here, and I always like to go ahead and put in I have 20 grams of hydrochloric acid, and I need to know how many grams of sulfuric acid is. So we're looking for this right here. So we're going to put that nice and bright so we can see it. Okay, so that's what we're looking for. We have this, we're looking for this, so we're going to start off with this right here. So I'm going to scroll down just a little bit, and we'll put in our 20 grams of HCl. And as always, we're going to put our times in a line, times in a line. But again, we're going to go back to the stoichiometry problem, or stoichiometry map. So let's look at the stoichiometry map and see what we have to go with that. Okay, here's our stoichiometry map. We're going from mass to moles. So I need to put the molar mass in grams of the compound of hydrochloric acid, and that's going to equal 1 mole. So let's go back to the question. So we know that we're going to put 1 mole of HCl on the top. And on the bottom, that's going to equal our grams of HCl. And what is that? Let's go ahead and just figure it out right now. It's pretty simple. I only have 2 elements. I have hydrogen, which is 1, and chlorine, which is 35. So I think it's going to be 36 grams of HCl. Let's double check it. And again, this is one thing that I don't have to write down if I can do it and make sure I'm correct. So let's go back to the periodic table. Again, scroll all the way back up to the beginning. And we know that hydrogen is 1. There we go. Chlorine is 35. So if I have 1 of each, it's 36. So we're going to go ahead and go back there. And we're going to do our next step. Well, our next step, it tells us that we actually put in times and a line. And if we go back to our stoichiometry map, okay, our stoichiometry map tells us that we have to go ahead and do our molar coefficients. We'll put our moles of hydrochloric acid on top, and our moles of sulfuric acid on, I should say, our moles of hydrochloric acid on bottom, and moles of sulfuric acid on top. So we're going to go back to our problem, and we're going to put in where we're going to get these. Well, we're going to get our moles of hydrochloric acid right here. So I have 2 moles of hydrochloric acid equals 1 mole of sulfuric acid. So I can go to the bottom, and I can put down 1 mole of HCl is going to equal, and that's not 1 mole, it's 2 moles, because I got to do that one, 2 moles equals 1 mole, equals 1 mole of H2O. SO4. Okay, so we have that one. Now we're going to go from moles of this. We're going to underline this real quick. And we put our times in a line. And again, a reason that we're doing this is because that's our next step. We'll go back to our stoichiometry map. Excuse me, I didn't want that one. Go back to our stoichiometry map. Now we have it in moles. We're going to go molar, the moles on bottom that we have, 1 mole equals the molar mass of sulfuric acid. So let's go back to our question. And here's our question. So we know that we're gonna, on the bottom, we're gonna put down 1 mole of sulfuric acid. So we're gonna put 1 mole of H2SO4 on bottom, and that's gonna equal our molar mass, which is gonna be grams of H2SO4. Now we have to calculate out our molar mass. Now again, we could just add this together, and I'm just gonna do it in our head. So I look at it, I have 2 hydrogens, so on my calculator I'm gonna put a 2. I have 1 sulfur, so we have to figure out what sulfur is, and I have 4 oxygens. So I'm gonna go back here and in the oxygens, so I have 4, so 2 is 32, double that is 64. So we add to that 64, and now we just have to figure out the sulfur. The sulfur is actually 32, so we're going to add 32 to that, and that's going to equal 98. So we're going to put down 98. Now again, show your work. It'll help you out. We'll know where you make a mistake if you make a mistake. But I want to double check it, so I'm going to go back to the periodic table. As always, we're going to go back and forth. And we know that oxygen was 16, sulfur was 32, and hydrogen is 1. So let's go back to the problem. So hydrogen was 1, 32, and 16. And let's just go ahead and do that again. So if I had hydrogen times 1 is 2, plus my 32 from that. And then we had oxygen, which is 4 times 16 is 64. And that's going to equal 98. So we're good there. So let's go ahead and underline this. And we know that that's going to equal. Now, before I do anything, I want to make sure I'm going to cancel everything. And I can cancel it here. I can cancel it earlier. But I have grams of hydrochloric acid here. So we're going to get rid of that. And I have grams of hydrochloric acid on bottom. Now, remember, if I don't cancel these out, then that means that I need to put them in my answer. I only want one thing. The question's only asking for how many grams of sulfuric acid. So that's what I'm going to leave left. So I'm going to put moles of hydrochloric acid here, moles of hydrochloric acid down there. Get rid of that. Moles of sulfuric acid up here, and moles of sulfuric acid down here. So we're left with grams of sulfuric acid, H2SO4. Okay, so I'm just going to do the math, and with my math, I don't do anything with ones, remember, because that doesn't change the value. So we're going to bring our calculator back up, and we multiply by the top, divide by the bottom. So we're going to take our 20, and we're going to divide by 36, and then we go to the next step. We're going to divide by 2, and then we're going to multiply by 98, and we end up with 27.22. So 2222. So we're going to put in there 27.222. And let's double check that again. It sounds like it's about right. It sounds like it should be right there. So in here, we're going to take our 20. We're going to divide by 36. Then we're going to divide by 2. And we're going to multiply by 98. That's good. And so we ended with 27.222. So now what do we have to do is we have to check our answer. That answer was checked right, but we have to make sure it's in the correct number of significant figures. And again, always, most of the time, I like to go ahead and go, okay, significant figures, how many, and write it right up here. Okay, so I like to write down sig figs. I'm going to put that back in there. So how many sig figs is that? Well, here's my number. Now I know that the 2 is significant. So the 2 is significant, but are the zeros significant? If we go to the rules, we talk about trailing zeros. Well, trailing zeros are only significant if there's a decimal in the number. Well, there's a decimal in the number, so that means I need to have 3 sig figs. So again, that's something that, again, I like to make sure that I highlight, and we know that it's there. So we have 3 sig figs. So we go down the answer. We go 1, 2, 3, put my line there. We go to the number after the line. The 2 says we round down or drop it off, so we're going to get rid of that. And there's our final answer. Highlight that. Boom, we did it. Hey, we're all done. And that's how we do problem number 3 of practice sheet number 3. So, hey, as always, go Mohawks. Nelson out.